Let's try graphing one of these types of square root functions again. So this time we have y equals the square root of x plus 3. Let's make our table. This time everything's inside the square root. And again, I have to be very smart about what numbers I plug in for x. So since there's an x plus 3 inside, I want to think, what number can I plug in for x that will give me a 0 inside the square root? And that would be a negative 3. Negative 3 plus 3 is 0, and the square root of 0 is 0. Now I want to think, what number can I plug in that will give me a 1 inside the square root? And that number would be negative 2. Negative 2 plus 3 is 1, and the square root of 1 is 1. Another number that's easy to take the square root of is 4. So I could plug a 1 in for x. 1 plus 3 is 4, and the square root of 4 is 2. And then the last number that's easy to take a square root of that we would want to graph is 9. So I could plug a 6 in. 6 plus 3 is 9. The square root of 9 is 3. Now I have some negative numbers on my graph. So my first point is at negative 3, 0, negative 2, 1, 1, 2, and then last at 6, 3. So our square root graph will look like that. The domain of this graph will be x. Let's see, the smallest number that x can be is negative 3, and then it just gets bigger. So x is greater than or equal to negative 3. And the range, it looks like that the smallest y is 0, then they just get bigger, so y is greater than or equal to 0. So now we have a graph that kind of combines all the stuff that we learned into one function. We have a 2 on the outside, we have a plus 4 in the inside, and we have a negative 1 on the outside. So let's make a table, and we'll be very careful about what we plug in and make the graph for this function. So, since we have the plus 4 inside the square root, we have to think, what should be the first x value I plug in? Or what x can I plug in that will make the square root go to 0? So the first x that I'm going to plug in is a negative 4. So we have 2 times the square root of 0 minus 1. Well, 2 times the square root of 0 is 2 times 0, and then minus 1 would be a negative 1. The next number I want to plug in for x is something that will make the square root go to 1, so I'm going to plug in a negative 3. So here we have 2 times the square root of 1, which is 2. 2 minus 1 is 1. Okay, now I need to find an x value that if I plug it in, it will make the square root go to 4, and that would just be a 0. So we have 2 times the square root of 4. The square root of 4 is 2. 2 times 2 is 4. 4 minus 1 is 3. All right, and let's do one more. I'm going to plug in a 5. So we have 2 times the square root of 9 minus 1. The square root of 9 is 3. 2 times 3 is 6. 6 minus 1 is 5. So there is our graph. So we have to be very careful when we're doing the calculations in the middle. So we have our first point at -4, -1. Our second point at -3, +1. Our next point at 0, 3. And our final point at 5, 5. So our square root function will look like that. The domain of our function, well, our smallest x was -4, and they went up from there. So x is greater than or equal to -4. Our range, our smallest y is at -1, and they went up. So y is greater than or equal to -1. Try these next problems on your own. Pause the video and then replay it to see if you were able to graph these functions correctly. This is the correct graph for problem number 5. Notice that the -6 is inside the square root, so we need to be very careful about what values we plug in for x. So we should have plugged in a 6 first, because 6 minus 6 gives us a 0. For the domain, you'll notice that the x's start at 6 and go up from there. So that's why we have x is greater than or equal to 6. And the range, the y starts at 0 and goes up. So y is greater than or equal to 0. Now number 6 is pretty tricky because we have this x minus 1/2 inside the square root. So you have to think, what numbers should I plug in for x? Well, in order to get x minus 1/2 equal to 0, we should plug in a 1/2. 1/2 minus 1/2 is 0. 1 and 1/2 minus 1/2 is going to give you a 1. 4 and 1/2 minus 1/2 will give you that 4 that you're looking for, and 9 and 1/2 minus 1/2 will give you a 9. So our domain is x is greater than or equal to 1/2, and our range is y is greater than or equal to 0. Now this graph was pretty tricky, so good job if you got it correct. For our x's, we need to make sure that we're plugging in values that will create perfect squares. So we plug in a -2 to create a 0, a -1 to create a 1, a 2 to create a 4, and a 7 to create a 9. And be very careful with your calculations going on in the middle. Make sure that you're taking the square root of the number first, then multiplying it by -3, then subtracting 6. As you can see, our x values start at -2 and go up. So our domain is x is greater than or equal to -2. Our y values start at -6 and go down. So our range is y is less than or equal to -6. This last graph was pretty tough too, because we had to deal with some fractions. So again, we have an x minus 5 inside the square root. So we want to make sure we pick numbers that will make the square root equal 0, 1, 4, and 9. Then make sure that you do the square root of the number, multiply it by a half, and then subtract 3. So as we can see in this graph, our x's start at 5 and then go up. So our domain is x is greater than or equal to 5. And our range starts at -3 and it also goes up. So we get y is greater than or equal to -3. Notice that there's a 1/2 on the outside, and see how the y values are always increasing by a half? That's a little trick to check and see if you're getting the right solutions. So if you got all of these graphs, or most of them correct, give yourself a pat on the back. These are pretty difficult, so good job. This concludes our notes for section 1 of chapter 11. Remember, you can always re-watch any of these videos or any of these problems to further understand them. We will be doing the homework assignment in class.